So hello and welcome to the continued coverage of the walkthrough series, and in this episode we're looking at 9618 forward slash 42 of May June 2025, and in this episode we are looking at number 2 for the Java implementation. So let's go ahead and check the question out here. So we have a program. The question says a program stores data in a 1D array of records, hash table. The array is space for 200 records. Each data item is stored in a specific index of the array that is calculated using an algorithm. The index is calculated from the key field using the formula key mod 200. If two key fields generate the same index, there is a collision. Any records that have a collision are stored in a second array called spare. This array is space for 100 records. When a collision is detected, the record is stored in the next free space in spare. So we are given the pseudocode for the record. It's called new record, and essentially we are supposed to create this new record, as it were. So let's go ahead and look at the information that I have going on here. So for my implementation, if you come back to the question, you see that they say if your program, rather if your language does not support record formats, you can always create a class instead. So that's what you're going to do in Java. So instead of having the class in a separate file, I just made sure that I put it in the same file as my question 2J 25 variant 42 Java file, as it were. So I only have one file that I'm working with in this particular solution. If you want to do the same thing, just make sure that the class is not public. Just make it a class that resides in the same file as your public class with the question name there. So you see that we have the variables in the record, as it were. So we have the key, the item, and the item 1 and item 2. Then of course, since this is a record that you are going to be creating new records with, you also need to have a constructor for your class, is it? So the constructor is right here. So whenever we initialize a new record, the constructor is going to be called, and it's going to require you to supply these 3 parameters upon creation. So of course, that would mark the end of the solution to part A, and you'd go ahead and copy this code and paste it inside of your evidence document. Part B item 1 says write program code to declare the global arrays hash table and spare. So coming back to the solution, since these are global variables, now we are moving inside of the second class, that is our main class, as it were. So it's starting on line 18 all the way down there. So since these are global, it means they have to be declared outside of any methods or outside of any functions, as it were. So we are making them private. Then these are going to store, if we come back to the question, you see that they are going to store arrays for hash table, and hash table it's going to store an array of records, is it? So we know that our record is of type new record, the class new record. So that's going to be our data type right here. Then the name is hash table. Then it's going to store 100 elements. Then spare is also going to be the same thing, but the only difference is going to be the name as well as the size of the array, the 1D array. So of course you'd go ahead and copy this code and paste it inside of the evidence document. Then on moving on with the question, we have the B item 2. An empty record is the integer -1 stored in each field. The procedure initialize stores an empty record in each element in hash table and spare. Write program code for initialize. So coming back to the code here, B item 2, you see that we have the implementation going on here. Our function doesn't return anything, so initialize is a void function. Then we are essentially using 2 loops to initialize the variables or the elements rather inside of hash table and inside of spare to the specified or to the required values, is it? So both array elements are supposed to be initialized with values of -1. So that's what we are doing there on lines 23 to 28. Then of course you copy the code and paste it inside of your evidence document. Then part C, the hash value is calculated from the key field using the formula key mod 200. We had been told this earlier, but they're just reminding us how the formula is being applied. So the function calculate hash takes a key field as a parameter and calculates and returns the hash value for the key field. Write program code for the calculate hash. So the implementation is right here. We are simply going to have return an integer, then we are going to calculate a hash value, and it takes a parameter of type key, which is an integer, so this is the type. Then we are simply going to return the key modulus, the number of elements, is it? Because this is the formula that we are given here. So key mod 200, and the modulus function in Java is the percentage sign. Then of course you copy the code and paste it inside of your evidence document. Part D, the procedure insert into hash takes a record of type new record as a parameter, uses calculate hash to calculate the hash value for the key field in the record, checks if the hash value index in hash table currently stores an empty record. Then if there's a collision, remember they said that you're supposed to move it to space, so that's what these two if statements are talking about here. Then you can always assume, there will always be enough space in spare to store any collisions, so we don't need to worry about spare filling up at any time, because they said you can always assume that there's always going to be space. So our task for this part, that is part D, is to write program code for insert into hash that satisfies these requirements right here for 6 marks. So let's look at the implementation that I have going on here. So our function header, you can see that is a void function because it's not going to return anything according to the requirements here. Then it has a parameter of type new record, so we specify that and we call that parameter record. Then we are calling calculate hash. Then calculate hash is going to return an integer, so we are going to store that integer inside of hash. Then we are using this if statement to satisfy the first condition and see if the hash key is equal to -1, right? Then we are simply taking that record and storing it at the specified index position inside of hash table. Then we are also going to, should that not be the case, if that if statement doesn't execute, then we are going to perform the second if statement, so that's when we have the else here. So we are simply going to iterate through the array spare and check to see if the space is empty. Then we are going to store that record inside of spare should there be a collision, is it? So that is how you can satisfy the conditions specified there. Then of course you can copy the code and paste it inside of the evidence document. Moving on to part E, the text file hash data.txt stores up to 200 rows of data to be stored in the hash table. Each row contains 3 integer numbers separated by commas. The first number is the key field, the second number is item 1, and the second and third number is item 2. For example, you see that we have this example going on here. So this is the key item 1, item 2, right? So our procedure create hash table should open the text file, create a new record for each row of data in the file. Then it's going to call insert into hash for each record. Then we are supposed to write program code for the create hash table function. So let's go ahead and look at the implementation. But before we do that, let's just take a look at the hash data. You see that this is the hash data as they specified in the requirements or in the description. The first element, like if you are looking at line 33 here, this one will be the key, this one will be the item 1, and this one will be the item 2, is it? So we are supposed to read each of these, each row or each line from this text file and use it to calculate our hash, as it were. So looking at the solution here, we are using, again, is a void function because we weren't told that it returns anything here. So we have the buffered reader class and the file reader class. You always use these classes to read your files in Java. Then the file that you want to read is the hash data.txt file. Then we have a blank line that we are starting with, or just a line, a string, that's going to hold a string, as it were. Then if the current line is not now, we are simply going to split where there's a comma. Then after splitting, so when we split, let me open the text file right here so that I can explain how it works. So if you look at the code here, we are going to pass the element at 0, the element at 1, and the element at 2, is it? So we are taking each line inside of hash data. Like let's say if we take this line right here, we are going to store this line inside of pass, right? So inside of parts. So we are going to store this line 111 is going to be stored inside of parts. Then what we are going to do with it is now we are going to take the first part inside of parts, right? We are going to take we are going to split the elements where there's a comma. So essentially, when we split the elements where there's a comma, we are going to have 95, 12, and 54. That's what we are specifying right here on line 55. So when we do that, we are going to have an array. Remember, this is an array called parts, right? So it's now a string array that has 3 elements in it. So we take the first element, pass it to an integer, and store it inside of key. Then we take the second element, pass it to an integer, and store it as the key as well. Then we take the third element, pass it to an integer, and store it inside of item 2 right there. Then after doing that, we simply call the insert into hash method, and we create a new record on line 59. Then we are going to continue doing this until we have exhausted or until we've come to the end of all the elements inside of our array. And by then, they will all be inserted into our hash table. Inside of our hash, as it will. Then line 61 to line 65, we are just using exception handling to print any message should we be unable to read from the file, as it were. Then of course you'd go ahead and copy this code and paste it inside of the evidence document. Then line F, rather part F says we should create a procedure called print spare that's going to output the key field of each element in the array spare that does not contain an empty record. So we come to the print spare function right here. So we are using an enhanced for loop to iterate through the spare array. So we are simply checking to see if the current key is not equal to -1, then we simply print that array right there. That key rather, as it were, right? So remember, record is of type record, then you're just printing the key because they specified that we should only print the key and nothing else. So we are not going to be printing item 1 and item 2, as it were. Then of course you can copy the code and paste it inside of the evidence document. Then the main program should call the procedure to initialize the arrays, call the procedure to create the hash table, and then call the procedure to output the contents of the array spare. Write program code for the main program. So our main method is here. We're just calling initialize. So they said you should call initialize, call the procedure to create a hash table, and the procedure to do that is called create hash table. So we call initialize, we call create hash table, then we call print spare. Then you can copy the code and paste it inside of your evidence document. Then test your program, take a screenshot of the outputs. All right, so you can come here and make sure that I save everything, then hit on the play button here. So you see that you get the output. This is what's going to be inside of the spare array. So yeah, that marks the end of this implementation to question 1. I'll see you in the next video.